Okay, you guys, this is the second part of your topic 2 review. And in this section, we're going to specifically review writing proofs. I wanted to remind you guys that sections 2.1 and 2.2 notes and videos contained proofs. So re-watch those videos if you want additional examples of writing proofs. But I'm on page 71 of your workbook. And number 10 is a problem that asks us to write a 2-column proof of the alternate exterior angles theorem. So we're going to break that down. The alternate exterior angles theorem, if we remember, tells us that if two lines are parallel, then alternate exterior angles are congruent. And in this example, angle 1 and angle 2 are alternate exterior angles. So what we are going to do is we are going to write down the mathematical reasons as to why that theorem is true. So we are going to write down the reasons and create a proof as to why, if two lines are parallel, then the alternate exterior angles are congruent. We are going to prove that. So just a reminder, if we are proving the alternate exterior angles theorem, that means we can't use it as a reason. We're trying to use other math things to support this theorem. So here we go. We've got our 2 columns, and we were given that M is parallel to N, so we write that as our first statement and our first reason. So I state that lines M and N are parallel. I was given that information. So here we look in our diagram and we try to see what can we notice about anything going on here. Is there something you notice about angle 3? You probably notice that it is across from angle 2, and therefore they are vertical angles. So I'm just going to state that. I'm going to state that angle 2 is congruent to angle 3 by the vertical angles theorem. Okay, cool. I know that. We know that vertical angles are congruent. I'm going to zoom out a little. All right. Well, is there anything we can now see about angle 3 and angle 1? Are they related in any way? They are. They are corresponding angles. And we know that corresponding angles are congruent. So I can say that angle 1 is congruent to angle 3 by the corresponding angles theorem. I can use that theorem 100%. I know that 3 and 1 are congruent because of that theorem. So now let's remind ourselves what we're trying to prove. We want to prove that 1 is congruent to 2. Well, here's what we know. We know that 2 is congruent to 3. We know that 1 is congruent to 3. So therefore, by the transitive property of congruence, angle 1 must also be congruent to angle 2. If 2 is congruent to 3 and 1 is congruent to 3, then 1 and 2 are congruent. And we did it. We proved using other mathematical reasons, actually just using, the vertical angles theorem and the corresponding angles theorem. That's why we can say alternate exterior angles are congruent. We did that in 4 steps. Okay, there's another proof we're going to do on page 80, and that was in the next section. And it tells us, it says write a flow proof. We don't do flow proof, so you can just mark that out. We're going to just write a 2-column proof of the converse of the alternate exterior angles theorem. So we first have to remember what the alternate exterior angles theorem, the converse of that theorem, tells us. And the converse says if angle 1 is congruent to angle 2, then the lines are parallel. And we're going to prove that. So you can pause and sketch this figure. This is just a diagram from the converse of the alternate exterior angles theorem. And that theorem states that if alternate exterior angles are congruent, angle 1 is congruent to angle 2, then the lines are parallel. And we're going to actually prove that those are parallel lines. So we're given in the converse of the theorem statement that angle 1 is congruent to angle 2. So we write that as our first statement, and we are given that in our theorem. And now we're going to do like pretty much a very similar process. We're going to think through what we know about angles and what we can state about them. All right. So now, is there anything here you notice about angle 2 and angle 3? Oh yeah, just like in the last problem, angle 2 is congruent to angle 3 by the vertical angles theorem. The vertical angle theorem says that angle 2 and angle 3 are congruent. Okay, let's think from there. We know that 1 is congruent to 2. We also know that 3 is congruent to 2. So that tells us that angle 1 is going to be congruent to angle 3. By the because of congruence is transitive, so we can just put transitive property of congruence. And now think about, because we're thinking backwards, you now just know that 3, we've proved that 3 is congruent to 1 via transitive. So is there any theorem that states that those lines are going to be parallel? Yes. We can say that L is parallel to M from the converse of the corresponding angles theorem. Because the converse says that if corresponding angles are congruent, then the lines must be parallel. And we just proved that these angles are congruent, so we can 100% conclude that the lines are parallel. You'll have a Math Excel review to help you review writing proofs.